Hey there, YouTubers. Alright, in the last video I said that I would explain a little bit more of the physics behind this two-stage mechanical oscillator. So somebody left a comment in the last video saying that this weight on the lever was almost nothing. Okay, well, that's true, that it weighs almost nothing because of the counterweight. Well, yes, that's absolutely true, because if it's just sitting there, yes, it's not gonna, that's what it's gonna be. Of course, I can probably, I'm not sure if I can lift this with a pinky here, but yes, I can lift 24 pounds with my pinky because of the counterweight over there. So yes, this weighs very little because of the counterweight over here. But the thing is when it's in action, then things completely change, and that is no longer the true. So now, when this swings up, when it's at its highest point on each side, let me see, I think I got this zoomed in a little. Nope. When this is at its highest swing on each side, like that, at that point in time, that very small split moment of time, those weights are effectively weightless. And when they are weightless, then all the weight on this side drops at its full impact. So when the weight of the pendulum comes swinging back down right at this point where it's at now, all the weight pulls down and lifts the weight on the lever, just like that. And this is how it goes up and down. So and then when it swings back up to the other side, it's weightless again for a split moment of time, and all the weight on the lever goes all the way down. It does this twice. It lifts the weight on the lever twice per cycle on the pendulum. So one cycle would be starting right here. This would be one cycle, and then when it comes back. So when it goes down this way, it pulls the weight. It pulls the weight up. And then when it goes back up, it becomes weightless. It drops the weight. When it comes back down, it lifts the weight again. And then when it gets back up here where it started, it's weightless again, and it drops the weight one more time. So it lifts this weight twice per one cycle over here. We'll show that here in a second. Another thing is that the output right here does not reflect back to the input. And I'll show that too here in a second. Normally, like let's say this was a motor, with a spinning rotor or something like that, a generator, and you pull current from the generator, it makes the Lenz's law opposing field, and that slows down the rotor, and that's the loading effect. And then you got to put more energy into the input to overcome the energy that you're taking out of it, or to put the energy back in that you're taking back out of it. Well, this doesn't do that. This you can load this fully down, and it will not affect that pendulum swinging and the weight. So let's look at this. Do it again. Get it up to its highest point we can on the swing, and it doesn't put a lot of, you don't have to put a lot of input into the forward pushes. Okay, there it goes. Now we got this swinging. It's going up and down right there. Give that a little bit more of a, keep it up. And there it goes. You can hold it down, and it does not affect the pendulum swinging in any way at all. Here, let's do this. Give it a little more of a push here. Hold it down. Still swinging. And let's take this out. See, it's still lifting it. The output does not reflect back to the input. Now, this looks like it appears that this is actually breaking one of Newton's laws of action and reaction. For every action, there's an opposite and equal reaction. Well, here the reaction doesn't look like it's reflecting back to the original action. So there's something to ponder on and to think about. Let's see, what else do we got here? So, oh, I added another weight. So this was just 18 pounds. Now it's 24. And this thing requires tuning, just like every other system out there that has an oscillation. It basically needs tuning. This has to be at a certain distance away from this, and this has to be at a certain distance. And I find that when this distance is of roughly twice the amount of distance of this, and this has roughly twice as much weight as that, then it becomes more synced up. And the idea is to get that hammering effect going up and down, and to get a pretty successful working device to do what it's supposed to do. I don't think I'm going to add any more weight to this. I almost have used every single weight there is, except for two over there. Those are the only ones I didn't want to put that on. But so now the idea is to, and there are many other versions of this. There's the anti-gravity motor. It uses gyros, but that's a whole nother thing. But other versions of this are, you can actually create the pendulum swinging, and then you could put your other weights right here and make them go up and down directly above your pendulum weight. And it works like that too. You can also make a cart, which I think I'm going to start working on that next, because it seems pretty simple. It's a cart with 4 wheels and a pendulum that swings on top of it and creates extra thrust, a one-way thrust, which is supposedly an extra force that is created from the pendulum. Sort of like what this is, the pendulum creating sort of like a thrust on this by pulling the weight up and then dropping it. And this is very real weight, because it would crush my pinky. So, you know, I don't think weight that's nearly like weight, doesn't have any weight to it because of a counterbalance would, you know, then it wouldn't crush my pinky, but it would. So it's a very real weight. So let's look at this from one more angle, and then I hope I explained that, a little bit of the physics on it a little bit. And you know, you could probably write a 20-page equation on this device, and all in Greek symbology, and I wouldn't be able to understand it. It'd be a completely different language to me. But the math that I do know, it's a basic equation that works and relates directly to this, is force times distance equals work. And so we get a little bit more, what appears to be more work out and energy than what we're putting into it, because it only requires a tiny little push right here on the pendulum. The only energy lost okay, in the pendulum is only in the friction of the bearing right here. And a little bit of air friction. That's the only thing. That's the only thing slowing this down, and so that's the only thing you have to put into the system to keep the energy stored and to extract the work through the extraction lever here and get work out without reflection back to the input. So I hope I explained that okay. If I left anything out, let me know. If you have anything to add, let me know in the comment box, and please feel free to share this video at your own inclination. And thanks for watching, and I'll see you on the next one. I believe the next video I'll try to get some measurements in. I was thinking about like a belt tension gauge for measuring belt tension on cars. I think that would work very well. So hope that was a good explanation for you. I'll try to get everything in there. So I guess I'll see you later on the next video. Have a good one.